Okay, well, good morning to everybody. Um, my goal here is to provide you with a short introduction on cloud computing. Um, Please feel free to interrupt me at any time if you have questions. I guess there's a mechanism where I can see that you have a question, and I'll try to take a pause and respond to it. I'm assuming that the audio is going through okay. Okay, so cloud computing is becoming a very important aspect of the IT industry as well as academic research, and it is becoming a dominant modality for doing computing, and there are very good reasons for it. The first slide here is trying to highlight the growing importance of cloud computing, and it presents some text from recent reports that show that it is really becoming very dominant in an industry, becoming a huge market for cloud services out there, and a lot of industries are transitioning to it. And so it's clearly something that is becoming is going to become a very dominant and integral part of our IT infrastructures move along, right? And there's a very good reason for it. As I mentioned, it provides a very seductive abstraction. So what cloud does is it gives you this abstraction of unlimited resources which are always on and are always accessible. These resources, whether they are software, hardware, platforms, they are easy to use as a service, and most interestingly, they are on demand. So you can scale up when your demand increases, and when you don't need those resources, you can scale down and possibly even scale out to other cloud infrastructures. From a business point of view, it gives you a very attractive business model. It allows you to exploit economies of scale. It builds on a pay-as-you-go model where you have to pay for what you use and only what you use. And so this becomes very attractive to small and medium businesses and other organizations that can make use of such a capability. And clearly, the IT in industry has been transformed by cloud, right? You see outsourcing to as a service abstractions. You see consolidation to improve utilization. And you see a result of this, a dramatic cost saving in IT costs. And this is especially true for small and medium businesses. And so clearly it's a very attractive model. And that's the reason why it has really transformed the marketplace, the IT space today. And clouds are here to stay. A recent report by Gartner said that it anticipates that clouds will be a $149 billion industry by 2015, and that's clearly huge, right? And so the goal of this presentation is to really understand what are clouds and why is it becoming important now. Many of the ideas and concepts that underlie cloud computing have existed for 20, 25 years now. So why is it that at this point it's becoming such a dominant paradigm? Okay? And then what are the trends? And finally, I'd like to close with exploring what role clouds can play in science and engineering from an academic perspective. Okay, so cloud computing, the what and why, right? So one way to look at cloud is more as an evolution than a revolution, right? And if you think of the progression from the internet moving on to the web and the grid, cloud seemed to be a very natural next step, right? The internet was all about connectivity. How could I connect different entities more seamlessly? If I go beyond that, we had the era in the early 2000s of the web and the grid. And the idea there was more about building on that connectivity and providing information exchange, computational aggregation and exchange, e-commerce, more in terms of exchanging this information in this web and aggregating it in this grid, right? And if I look at the next natural step is then the idea of the cloud, where we are now, instead of providing information and computation, you're now talking about services, right? So now you don't have to access information, but you can actually use a service that's hosted remotely, right? And that could be a natural evolution, and that's one way to look at the cloud, the way it has emerged from the concept starting from the internet and really realizing the original dream of computing utilities in the form of clouds and as a service abstractions. Again, this is another picture that goes back to the point I made, that if I look at the cloud today, it is growing extremely rapidly, right? And if you look at cloud revenues, they're already becoming a significant part of the marketplace. And what does that mean? Well, the cloud of cloud service providers is growing as well. And right here, you've just seen some of the service providers, but if you look at it, it is pretty huge, and it's growing every day, right? And it's going to just keep on growing because people will find new ways to deliver different types of services using this abstraction, right? And so that's what really makes it so attractive. It allows you to be able to access and outsource capability, and as a provider, it allows you to provide capability in a really democratized marketplace, and that makes it very, very attractive. Okay. So let's try to define the cloud, right? And clearly there's no single definition. Here are two that I picked out. The first one is coming from Wikipedia, and I'll let you read it. It tries to define clouds in terms of internet-based computing, right, on the network, whereby shared resources, software, and information are provided to computers and other devices on demand, like a public utility, right? Another more formal, or a little more formal definition comes from the NIST. That's the Standardization Institute here in the U.S., which says a cloud is a computing capability that provides an abstraction between the computing resource and its underlying technical architecture, whether it be services, storage, network, enabling convenient on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service-provided interaction, right? So here's a more formal definition, right? So, and then if you search on the web, you'll find many more definitions that are different permutations and combinations of these concepts, right? However, even though people don't agree with what it means, everything in the internet, every business, every product, every service or capability out there will come with a cloud computing logo in it, because now it's become an accepted part of the business model for all IT companies right now, right? And there are some bottom lines behind it. It's really changing the economics of computing from being a capital investment to a utility, right? It's analogous to electricity. You no longer buy generators. Sometimes you have to, but typically you buy electricity where you pay for what you use as a utility, right? And computing can be thought about in the same way, right? It's also changing the way software is developed, right? In the past, hardware provisioning and deployment was always a separate part of the software development life cycle, right? And the programmer did not typically have to deal with it. But now it's part of the software development life cycle where the programmer has to think about it while developing the service, because now you can provision hardware and deploy from within your software by using these web service abstractions that are provided. Okay, and it also automates a whole bunch of infrastructure-related tasks and activities, leading to efficiencies and cost savings. Right. So there are clear advantages, and that's why it becomes a good business model for companies providing services. Right. So if you try to take this definition a little further and see what are the key components of the cloud, I look at it as really three key pieces. You have a notion of a user coming in from some sort of a portal, right, connecting to resources using web service interfaces, and these web services, these resources are hosted in some data center somewhere on using virtualization as a technology to be able to provide you with these resources, right? So you have the notion of some backend which is hosting it, which is typically virtualized. You have a web service interface that provides you with access to it, and the third piece is the notion of an SLA, right? Which means that in addition to getting the service, I have some agreement, right, which says that I'll pay X amount, and in return for this, I'll get a certain type of service from that service provider. And that service could be at different levels. It could be software, it could be a platform, or it could be an infrastructure. And I'll talk a little more about these different levels at which the service can be provided, right? So these are the basic pieces of, no matter what the definition is, these are the basic pieces that one can think of a cloud made up of. Some set of users coming in from some form of a portal, connecting to some back-end infrastructure. It could be distributed, it could be in a single data center, right, through web services, right? The back-end infrastructure typically uses some form of virtualization to host services that are being provided. And there's a notion of SLA which governs what type of return you're getting for what you pay for your service, right? And those are the key pieces, right? And so that you can look at cloud from two ways. You can look at it as a business model where I can provide services that I have at different levels and provide them to clients, right, so that they can use them and pay for what they use. And so it's a very attractive business model. But one can also look at clouds as an abstraction, right? From a user's point of view, it gives you an abstraction of on-demand access to resources. Again, resources could be software or hardware or platforms or information, right? It gives you access to these in an elastic way where you pay for what you go. You don't have to really bother about where it's hosted, how it's hosted, what technology, what is the type of data center, how many servers, how are they powered, how are they cooled. You don't worry about any of that. You get a very easy to use abstraction to access those services, and you pay for what you use. So from a user's point of view, cloud is a very convenient abstraction. From a service provider's point of view, it's a very nice business model for monetizing some services or resources that you have, right? So it's a very, very good match between the two, and that's probably one of the reasons why it is so successful. So this slide goes into a little more detail about the type and variety of clouds that one can come up with, right? If you look at the left of the picture, there are the typical cloud stack where you have the physical resources. Then the first level of abstraction one can provide is the bare bone infrastructure, where you get a virtual machine. It's bare bone virtual machine where then you can load up the operating system of choice and the software stack of choice for your business, right? And this is infrastructure for service. And the most common example of this is Amazon's EC2, right? And then the next level up, you can now think about, instead of providing the basic hardware, you can provide a set software stack which has containers within which you can build your application. And a good example there is, for example, the Google App Engine, right? So now I have the basic services in which I can develop my specific application and deploy it, right? And the deployment, the elasticity, scale out, scale up, scale down is taken care of by the platform, right? All I do is within that API and within that programming system that the platform gives me, I can customize it and build my own specific application, and then it gets deployed and executed and managed within that platform. And so that gives me some flexibility, right? But not as much as infrastructure as a service, because I'm constrained by the platform within which I'm building my application. But it also gives me a high level of abstraction, because I don't have to worry about configuring an operating system and the entire software stack. And if I raise it one level higher, now instead of building my own software, I can rent a certain software itself. For example, Salesforce, right? Or some other software, Gmail, right? I can use existing solutions that are hosted on the cloud, right, as complete solutions, right? And at this point, I have less flexibility. I have to use the functionality that this software as a service provides, but I get much higher level of abstraction. I don't have to worry. I just have to configure this specific service. I don't have to build anything. I don't have to program a specific application. I'm using it from the hosted software and service provided. And then people have built additional abstractions on top of this, such as database as a service and so on. And so you can build additional levels and additional types of services on top of that. But these are the most common layers in the cloud stack. On the right of this picture, you see the typical types of clouds, right? You have a notion of a public cloud, which means this is a cloud hosted somewhere outside my enterprise, right? I might be a company, and I might be using resources on Amazon's cloud or Microsoft's cloud or Rackspace's cloud, right? These would be public clouds that I can use outside. There is a lot of advantage for building what are known as private clouds, where I take my own data center and make it or provision it so that it can be used like a cloud, right? I build a software stack on my own data center, and then that becomes a private cloud. And in the later slides, I'll show you why there's a lot of benefit to doing that, right? Where if I'm using it as a private cloud, so basically what I do is within my enterprise, different business users in my enterprise, rather than each of them having their own data center, I can put them together, consolidate them to get better efficiencies, to get better economies of scale, and I can make it look like a private cloud within my enterprise, right? And sometimes I might use a combination where on an every daily basis, I use my private cloud, but when I have these peak demands, then I burst out to the public cloud, and then I get what's known as hybrid clouds, right? And then you can have other combinations like this as well. But these are typical. So you have a notion of a private cloud, a public cloud, and then a hybrid cloud. So let's dig a little deeper and try to find out why clouds are becoming such attractive solutions right now. Okay, so let's look at it from two perspectives. First, let us look at this from a provider's perspective, right? Data centers are clearly very, very expensive and time-consuming to build. Just from the back of the envelope and data that's out there right now, the recent reports, you can see that this can cost over $150 million and take years to build, to design and build, right? And so what does this mean? it means that I have to build it large enough, right? Since I cannot build it very often, I have to say, if you say I can build it once in 5 years, right? I have to anticipate what my need is going to be 5 years down the line and somehow build it so that it can accommodate that capacity that I'm looking for, which is very, very hard to do, right? And there's an increasing sizes, as my demands are increasing, the size of my data centers are increasing. Estimates have these data centers to be millions of machines in there, right? So the cost and energy consumption of these things, it becomes very important that these data centers are very efficiently and operated very efficiently and very highly utilized, right? So that I'm making good use of the investment. Now, if I'm anticipating capacity, what is my capacity going to be required 5 years down the line, then clearly I am over-provisioning for today's needs. So there's clearly a wastage today because I'm provisioning for what my needs are going to be 5 years down the line, right? But right now I don't have that demand, so I have to over-provision, right? And there's clearly a need that then I have to somehow take these costs that I've invested and amortize them across multiple users, right? And so what virtualization did was that, and consolidation did, was that they said that it doesn't make sense for us to build a lot of these small data centers. Instead, what makes more sense is that if I aggregate the IT requirements of all my business units and build a consolidated data center, and virtualization technology makes it possible, right? Then what I can do is I can then provide these IT services across all my units from a centralized, consolidated, and virtualized data center, and I can improve efficiencies and improve utilization, and I can get a much better utilization of my investment, right? And people have started, because of this, people start getting a lot of experience with very, very large data centers and grids, right? And realize that this is a good model. You get economies of scale, which makes it more attractive from a cost perspective, right? And so once people realized this, then it was, and you started building these consolidated large data centers, then it became a good idea that there might be additional capacity that I can then provide as a service internally or externally, right? And hence these infrastructure and platforms as a service concepts started becoming very, very popular, right? And if I'm a user, why would I go to the cloud? Well, I have very complex application needs, and it again goes back to the same problem, right? I have to somehow anticipate the demand in the future and provision for it. And if I cannot do that, then I'm going to have a problem. And so what clouds allows me to do is that I can, if I don't have the capacity to meet my demand right now, I can go and get it from the cloud, right? I can acquire it as a service from a cloud provider, and that allows me to be more effective even with these highly dynamic workloads without having to very extensively over-provision my data center, right? And the same thing is true with very dynamic QoS requirements. I have very different QoS requirements, and I have to be very nimble in the type of infrastructure I have to meet these different needs because they can change. And because I have this cloud, I can get additional resources or release resources as and when needed to meet whatever my objective is, right? The second most very attractive thing is that using clouds, I can transform my traditional capital expenses into operational expenses, right? So I rent resources on the cloud on demand and pay for what I use, right? And I pay for what I use rather than paying for the peak that I would be provisioning if I had my own data center. I avoid the risk of over-provisioning, right, which means that I don't utilize my resources, I have very poor efficiencies, and I have wasted, I'm wasting my resources and the investment associated with that resources. Or if if I under provision, well, I might have I may not be able to meet my SLAs. I might have lost revenue, lost users, which is even worse, right? And so most people are typically conservative and they over provision, and that leads to very inefficient use of those investments, right? And then finally, this concept of cost associativity is very important, right? In the cloud, if I use 1,000 computers for 1 hour, the price is same as using 1 computer for 1,000 hours. But if I have my own data center, this is not true. However, this flexibility gives me another dimension of how I trade off and use my resources most effectively, right? And so that's another thing that cloud gives me that makes it very, very attractive. Okay, so here are a couple of slides that go into a little more detail about just to make the point. Now, this chart that you're looking at right now is from IDC, and what it's telling you are what are the investments that are made on different aspects, right? The red line is how much am I the blue line, which is almost constant, the blue part of the bar is telling how much am I spending on new servers, right, on an average. The yellow is saying how much am I spending on managing those servers, and you can see that that is growing significantly, right? And finally, the more expense that's getting even more dominating as we're moving along and will become even more dominating is the cost of power and cooling those servers, right? And what clouds do is that allows you to outsource a lot of this. You can outsource a lot of the management costs, the power and cooling costs, and so you can get more effective utilization. And as these costs grow significantly and become very important parts of your budget, more and more enterprises will look at outsourcing these, and more providers will look at consolidating so I can reduce the impact of these costs by amortizing them over many users. And so both of these impact or make it an attractive solution is to have clouds or to go to clouds. The other piece is the maturity of virtualization technologies, right? And for those who don't know this, virtualization basically what it does is it allows you to create multiple virtualized or multiple virtual machines on a single physical machine. So on the left you can see a typical stack where you have the hardware, the operating system, and then you can run multiple applications on it. On the right you see a virtualized stack where basically you have a hypervisor that runs on the hardware, and the hypervisor is able to host multiple virtual machines, and the multiple virtual machines can run different operating systems, their own operating system. So now the application it looks like it has its own system where it's running, and you can have multiple independent operating systems and applications running on the same hardware, right? And so it allows you to get much better utilization from the hardware and host in a very effective way many different applications that might be very heterogeneous in their needs and their behaviors, right? And being able to do this in a robust and scalable manner allows you to build these cloud infrastructures, because now I can create a virtual machine with its own OS and application and host it on my data center for the different services that I provide. And it gives me a good way of really hosting these services that I'm exporting as cloud services. So I'm going to, in this next part of the talk, I'm going to dig a little more into these economies that I talked about, right? So the first thing I talked about was the economies of scale, right? So from a cloud provider, if I'm an enterprise and if I have a bunch of small or medium data centers, right, and if I think about consolidating them into a very large data center, you can see from a networking perspective, I can get a 7 times reduction in my cost, right? From a storage point of view, I can go down in cost by about 5 to 6%. And from administration, right, I go down by about 7, not percent, times. So I go down by about 7 times, right? So clearly, consolidation makes a lot of sense. If I'm an enterprise and if I'm having multiple business units with different IT needs, right, if I can consolidate them in a single data center, it's much more attractive to me from an economic point of view than building a data center for each business unit, right? And this is what a lot of the enterprises started doing. Given virtualization, they realized this and they started building larger data centers and sharing them across the business units rather than building one data center per business unit, right? And so what happened was, given virtualization, given consolidation, they started getting very good utilization, very good efficiencies, and they realized that they had additional capacity. And what Amazon did was, when it realized that in its data center there was additional capacity, it started finding a way to monetize this, and hence they started providing the EC2 infrastructure as service capabilities and selling them, right? Microsoft Azure is trying to do the same thing. Google also uses this infrastructure by providing hosted services there, right? So this becomes a nice way to monetize these additional capabilities that you get just by consolidating and virtualization and to improve your utilization and efficiencies, right? The second thing is from an application provider's point of view, right? Many, and we talked about this earlier in this presentation, many applications have very cyclic or very dynamic needs, right? And that can vary daily, weekly, monthly. And it's very hard to predict what these needs are going to be, right? Sometimes if I'm a hosting service for news event and something happens, right, you can see a sudden increase in traffic, right? Because everybody's trying to get there. And especially in today's connected world, this can be due to different events happening. It could be geographic related. It could be in so many different dimensions. It's almost never possible to predict what your demand is going to be, right? So what do you do? Well, there are two things you can do. You can provision for some capacity, right? And you hope that your demand doesn't exceed it, right? So the picture on the left shows you that you anticipate some capacity, the red line, and you hope that your demand doesn't go over it. And since you're trying to predict years down the road, you try to keep a good gap between the red line and your peak, right? But what does that mean? That all the line below the red line is going to be wasted resources. What you would like to be doing is a picture on the right where your capacity follows your demand. And what the cloud essentially does is allows you to achieve just that using this elasticity that it provides. Okay? And this picture highlights the fact that the gray part on the two curves, the shaded part is the part that you have wasted resources, right? That's what you're not using, and that's what's being wasted. And clearly, when you have the data center in the cloud, due to the pay-as-you for what you use and the elastic capabilities it provides, right? You can see that the wasted resources are significantly smaller in a cloud environment than in a static data center, right? And this is another point we've talked about. Picking this capacity is really non-trivial. It can depend on things that are totally out of your control, like we saw on the previous slide, right? There are certain events that happen that drive up demand, and you somehow have to catch up to that. Okay, and so what you end up is most enterprises, they over-provision significantly so that they are always covered, right? And they may be, very fraction of the year where they use that capacity, but the rest of the time, 90, 95, 99% of the time, you're not using all that capacity, and that's leading to a lot of wastage. On the other hand, if you're conservative and you do not, or you make a mistake in anticipating your capacity, what happens is that now you have under-provisioned, and which means one of two things happen. You basically are not able to meet all the demand that's there and you lose revenue, or you're not able to provide service, which means you lose your users and your clients, which is worse, if not equally bad, right? And so either ways, you're going to suffer if you under provision, right? And for most workloads, predicting where that red line, what the capacity line is very, very hard, right? And so most of the enterprises tend to over provision rather than under provision, because it's probably worse to lose revenue and lose users than to increase your cost. And that's what most of the enterprise end up doing, and that means that they have a lot of wasted resources and a lot of wasted investment that they have to deal with, right? And clouds give you a way to get around this. So given that you're convinced that cloud computing is something that is attractive, it has a good business case and meets a need, let's try to investigate some of the challenges in clouds. Well, it really requires you to change the way you're building software, which is fine for a company that's, a new company that's rebuilding its stack of a new software that's being developed. But for legacy, it becomes hard to translate it so it can fit to this model, right? Dealing with large amount of data has always been a problem and still continues to be a problem with current cloud infrastructure. How do you get the data into the cloud, and how do you get it out? How do you deal with data while it is in the cloud? There are a lot of system and application management problems, because now you have, from a provider's point of view, you're hosting many different applications with very different demands, and somehow you have to balance these very heterogeneous needs while meeting your objectives of economies of power and cooling, about security, about greenness, right? From a system management point of view, for a cloud provider, it just amplifies the challenges that you have, because now you're dealing not only the workloads that you know, but now you have unknown workloads that are coming in that you have very little control or understanding of, right? And this is a problem that keeps coming back, and I don't think there's a very good solution right now, and that's privacy, right? And I don't know how much of it is more of a human problem than a technical problem, but it requires some socialization for people to make that leap of faith, to give their data onto a third party. But people have already started doing this, and as regulatory mechanisms become online, I think this will become more acceptable for a lot of large enterprises to actually move their data into the cloud. But it still requires some amount of faith in the cloud provider. Security, right, is always hard, and cloud, because of the shared nature of the infrastructure and the hosting of resources, it makes security even harder. And again, people are working their solutions, but I think it makes the problem much harder given the nature and the usage models of a cloud. Reliability, right? When clouds go down, and you have seen this happen with when Amazon's cloud went down or when Google's cloud goes down, the impact is huge, because now you have centralized all the infrastructure across so many different enterprises. So if that infrastructure goes down, it impacts all the enterprises, and this is globally, that depend on that infrastructure. And that increases the responsibility on the cloud providers to have appropriate mechanisms in there and to be able to prevent against this. And it's hard. And in spite of all the investment, you still see a lot of things happen, such as recently Amazon's data center went down, and there's Google's had some problems with their data center, and you can see the impact and how the impact is truly global. And then there are other things, right? You might get locked up to certain vendors because you've moved your data to a certain format and a certain vendor, and now you're locked in there. You cannot, and that might impact you in many ways. What happens if that vendor goes out of business, or what happens? There are no interoperable industry standards that are still in the works, and so this is still an issue right now. Service level agreements are very simplistic. Building more complex service level agreements is hard, and people are still thinking about it. And then how to regulate these mechanisms is a problem. And then there are a whole bunch of society and legal and regulatory that people are really grappling with right now. How do you make sure that data stays within certain geographic regions? How do you make sure that it's not hosted somewhere? How do you make sure, what are the right, your services, your enterprises services might be hosted in a third country somewhere, and then which laws apply. So there are a lot of issues here that people are grappling with and studying as they realize that this is going to be an important part about how we do IT moving ahead. Okay, so just to summarize, there are many interrelated and often conflicting issues that must be addressed simultaneously in this kind of a cloud environment. And misbehaving cloud, if something goes wrong, it impacts a lot more enterprises, a lot more companies, a lot more users, and the impact can be truly global. And so you have to be very careful. Okay. There are a few killer apps that are emerging in clouds. Mobile apps, web apps, which are hosted on a cloud backend. There are extensions to Excel that are hosted in cloud type environment. There are a lot of use cases for batch processing, for MapReduce. There are a lot of use cases where people outsource a lot of their software processing. So more and more applications are coming on board, and clearly this is not complete in any way. But these are the classes of application that the early adopters brought onto the clouds. And this is a very incomplete list, but it's growing. Okay. So at this point, I wanted to switch to the last part of my presentation, and I wanted to leave some time for questions, and to see how cloud computing can assist science and engineering, right? Since I assume many of you are from academia and a lot of your work relates to science and engineering, I wanted to explore how science is changing. And I think there's a huge change in science that's brought about by this data, or the proliferation of computer and data that you see, right? There is a huge amount of data that's been collected by observation, by instruments, by scientific simulations that needs to process, right? And this is allowing you to do science at an unprecedented scale, right? It's a huge opportunity for science to be able to understand things that were not possible before. However, it also brings new challenges in the type of science that's data and computer intensive, that's really end-to-end with multiple scales and multiple physical processes going on at the same time. It's usually by teams of people that somehow have to collaborate, and they have to address all these challenges, which sometimes can impact the science itself, right? Because you spend all your time dealing with large amount of compute, large amounts of data, managing all of these things, managing the collaboration, right? And it's really impacting the productivity of the science in spite of having all these capabilities that we have, right? And what clouds can do, well, it can do what it did for the enterprise, for the IT in industry, right? It can outsource a lot of these mundane aspects of the complexity that cause the complexity that the scientist and the engineer should not have to deal with, right? So scientists are spending more and more time just preparing, right, to do the science, right? And if this part of it can be outsourced to cloud providers using the cloud model, that can really increase the productivity. So this is, the next 2 points are related to the fact that a lot of our times our capability to do your science, or even the scale at which we think in science, is limited by the resources that we have access to, right? And what clouds do is they provide me with this abstraction of a large set of resources that I have potential access to, right? So then I don't have to be constrained by the physical resources that I have, and I can explore science at its fullest. So it really increases my capability about conceiving, formulating, and then executing my problem without having to worry about the resources that I have, right? And it also democratizes access, right? There's a good correlation between the productivity of scientists and the access to resources, right? And if I can remove that barrier where everybody can now get access to resources because they have access to clouds, right? And so it levels the playing field, and everybody can have a similar or a same type of resources and can build science on that without having to have this divide between the haves of resources and have-nots. And so clouds have a real potential for impacting science there. But there are many challenges, right? Scientific applications are not really built in this IT-like cloud model. And clouds are not built to support these applications, right? And so there's clearly a mismatch that needs to be addressed by the research community. How do we build clouds, cloud services, cloud abstractions that are more appropriate for science? Can the addition of clouds enable science application usage modes that are not possible? So can we do things now that we have clouds that we could not do before, right? And that's important to think. And then what are the abstractions and systems that are essential to support these advanced applications on different cloud-like platforms, right? So clearly, science also has to move in this direction before they can use this abstraction and this type of infrastructure. So people have been doing this for some time, and there are three models that have emerged. One is really outsourcing the application to clouds, much like people have outsourced their IT operations to clouds, right? Can I run applications on clouds such as EC2? It gives me many benefits. It's easy to use, very easy to start up. You need a credit card, and that's all you need, and you have the resources that you can use. And certain applications do really, really well in these clouds, right? But there are other applications that don't do so well, right? So there's definitely some advantages that people can do by just running the applications. For example, there are some nicely parallel, also called embarrassingly parallel applications that have no interactions that scale very well into the cloud, right? And so those applications, this becomes a very effective platform. Two caveats there. One is that the people have noticed that the cost can quickly add up. Even though Amazon's base service is 10 cents per hour, per CPU hour, once you do real science with that, you can soon end up spending thousands of dollars very, very quickly, right? And people found that compared to more traditional models, clouds can come up to be if using current science practices, they can be extremely expensive compared to normal infrastructures. And part of the assumption here is that the infrastructure already existed, so it may not be a fair comparison, but still the point here is the cost of clouds can be non-trivial, right? But this can be a very interesting model to use clouds for science if I don't have resources or if I have a very suitable application, right? And there's some very obvious candidates, right? For example, parametric runs, where I'm running the same application on many, many different parameters, right? So I can run it in an independent with no communication. I can create, customize, and control environments while so I don't have to worry about keeping different versions of operating systems and compilers, because I can have virtual machines, and so that becomes an attractive model. And if I have a need where I don't have capacity, well, I can use the cloud, and that may be an interesting option to move HPC to the clouds. Okay, and there are certain characteristics of application that works well in this scenario. For example, loosely coupled applications, which means there's very little communication between them. Communication is asynchronous through files, so you don't need very fast networks. There's very little synchronization, very little I/O requirements, small, large messages or little communication, and lower core counts. Now this is changing a little bit with recent offerings from Amazon and other places which can do more than this, but still it still remains a specific niche that works very well in the cloud, right? But then once you go beyond this model, you can think about other type of applications. For example, one can think about reformulating applications so they're more cloud friendly. For example, one can think about a more asynchronous application that don't need a lot of messaging. One can think about clouds to provide new delivery modes. For example, I could have an Excel front end with a cloud back end, right? Or provide HPC as a cloud, where what I do is I try to build a cloud abstraction on top of more traditional infrastructure. I was just looking at some of the questions. I'll get to them right away, and because I'm almost wrapping up now. And finally, I could think about new hybrid infrastructure, assuming that we need a mix of all of these to really meet all our computing needs. One could think about where I'm running my high-end simulation on an HPC, but I'm doing my analytics online using cloud resources, right? So I can use these in some combined fashion. And these new hybrid usage modes is what would be emerging in the future. So I just wanted to end with something that we did some time back, where we tried to see if you can explore supercomputing as a service. And what we did was we took a more traditional HPC environment, such as the Blue Gene system from IBM, and we created a virtualization and elastic layer on top of it, where we could then provision it just like we provision EC2 to show that it can be very effectively used to both make it easier to use these resources, but to solve real problems which have very dynamic demands. And in this case, we were looking at an Ensemble-Kalman filter problem, which was doing an optimization for an oil and gas application, right? And it just demonstrates that one can start using this abstraction for more traditional scientific and use it very, very effectively. So I wanted to conclude now. So in conclusion, clearly the future is cloudy. It's becoming, clouds are becoming a part of production environments, part of the enterprise environments. They play a role in science and energy and engineering, because there are many benefits. Shift CapEx to OpEx, scale OpEx on demand. Startup and prototyping, very easy to get it off the ground. Cost associativity, it's the same cost whether they use one machine for 1,000 hours, 1,000 machines for 1 hour, and you can do research at scale. You don't have to constrain yourself with the resource that you have under your desk, right? Clouds are also transforming science. You can think of new applications, new delivery modes, new usage modes, democratization. There's also a very challenging research agenda. These problems are not all solved. And it's not just in the science of clouds, that how do I solve the problems in the cloud, such as security and privacy and all the other types of problems, but also how do I do science and engineering on the clouds. And finally, I think we have really focused a lot on how do I use clouds to solve all my problems, but I think it's a very powerful abstraction. And I think we need to think about, given this abstraction, how can I change and do new types of practices in science and engineering and business that were not possible before the cloud. With that, I wanted to quickly leave you with this just to bring us back to the ground. While it's very, very promising, this is the Gartner's, this is the hype curve, right? And it's just showing that while it's promising, we are still at the peak of inflated expectation, right? So there's a lot of challenges up ahead and a lot of opportunities for us researchers to look at, right? And but I think it's still promising and it's got a good future ahead. With that, I'm going to conclude, and I'll be happy to take any questions. I noticed there were a few questions already online, so I'll try to answer them. So this one says, education as a service are perceived as most appropriate cloud computing, and cloud services will have subject-wise resources. So I agree, delivery, and that goes back to my concept of democratization, right? Now, given this, everybody can get access to this, which was previously not possible, right? And through this cloud abstraction of as a service, anybody with some connectivity can get access to the same level of information, and that can really help. So I agree, this is a great opportunity to do education as a service. The other question was, for research pertaining to clouds, do I need to set up my own small cloud or can I use existing clouds? Well, it depends what type of research you want to do. If your research goes into changing the hypervisor or hardware, then you obviously need to build your own cloud, right? But if you can do it on top of an existing infrastructure and it's more at the usage level, then you could use a public infrastructure such as AWS. What is consolidation? So by consolidation, I mean combining things and putting them together. So instead of having multiple small data centers, you put them all together and have one large data center. So you consolidate all your small data centers into one large data center. I don't think they're okay. How cloud is useful for ERP system? I'm not sure what is ERP. So you might want to clarify that. And you're welcome. What is democratization? Democratization refers to something that provides equal access to everybody, right, without having, So basically through a cloud, everybody can get access to the same level and quality of resources that otherwise were not possible. What layer of the cloud stack is more vulnerable to attacks? I think it depends on the type of attacks, right? I think you can have attacks at all levels of the cloud. Clearly, the more flexibility you give the users, the more opportunity they'll have at the attack. So that if you provide an infrastructure, it might have more capability and more flexibility from someone who's trying to do mischief as well. Enterprise, okay, so ERP is enterprise research planning. Enterprise resource planning. So I'm going back to your question. Okay. So you have to remind me, I can't find your question now. I'm sure clouds could be used to provide resources. I don't know if there's a ERP as a service. I'm not aware of it, but it could be possible. What is a killer application? So killer application is a concept that's used to say what is the key application driver from the marketplace that will make this business model a success. And so So when you come up with a new technology, you're always looking for a killer application that would make it viable as a business. Is the SLA same for all countries? I am not sure if that is true. It depends on it may not always be true. For example, there might be people who might have different guarantees in different geographical locations, but I don't know if this is, what is the service landscape right now, an SLA landscape right now. What kind of open source tools can we use to simulate research findings? I'm sure there are some cloud simulators. I remember reading about something called Cloud Sim. You also have OpenStack, which is an open source cloud stack that you can use. I think you can get other things like Nimbus and Eucalyptus that you could use to build your own cloud environment and use that as a way of being able to do your experiments. Again, you could use the technologies that I talked about before, Nimbus, OpenStack, Eucalyptus, to build your own cloud. Can you talk about Bigtable? Well, Bigtable is an internal storage mechanism used to store information within Google. Hadoop created an open source version of this called HBase, and it's used by a lot of companies such as Facebook and others to store their information, to do lookups, right? It's a scalable, distributed way of storing information. What is supercomputing as a service? It's providing the capabilities of very large-scale computing, supercomputing, using the same model as infrastructure or software as a service. And that's what's being called as supercomputing as a service. Wanna conduct to cloud-based lab? Not sure if there's a question there. How are cloud used for ERP system? Again, I don't know if there's an ERP as a service. If there's computation involved, you could use cloud resources to help you do that. Okay, so how far Indian companies are using services of foreign cloud providers? I'm sorry, I don't know the answer to that, but I'm sure there must be a study somewhere. Maybe there are some statistics in Amazon that says what is the distribution of the usage geographically. What cloud, will cloud computing reduce IT jobs? That's a difficult question to answer. It may change the nature of IT jobs. I'm not sure if it's going to reduce it, or I don't know, read of any evidence that it is. But it will definitely change the nature of what IT jobs are and what what are the job descriptions associated with them. Can you name some of the free cloud providers? There are some academic clouds. I don't know how widely accessible they are. For example, there is the Future Grid, which is a platform, which is an academic platform, but I don't know of too many more. I'm sorry, I don't know of any others that are truly free. They're all, maybe you could think about the Open Science Grid as a free cloud. Nimbus, Eucalyptus, OpenStack, these are some of the open source software stacks for clouds. Does service-oriented architecture play a key role in cloud? So service-oriented architecture is a good way of building software, whether it's for clouds or anywhere else, and so it's a good architecture, good model for composing applications, and I'm sure it's going to play a big role in the way cloud stacks are built and used? Will encryption help protect data in multi-tenancy clouds? I'm sure encryption is one definite aspect of making multi-tenancy clouds secure, and there's a lot of research in using encryption in other models to be able to do that. But I'm sure encryption will definitely be one aspect of any solution that is out there. What model of cloud would be the right choice for start-up and small? It depends on the business. It depends on what they're looking for in the cloud. So I'm not sure without those details I can answer this. What's the difference between clouds and grids, please? So grid has been more about federation of specific resources to solve a problem. It's all about how do I connect different type of resources and bring them together to solve a specific problem. Cloud is more about elasticity and virtualization and using as a service, right? But there are also a lot of common aspects in the vision of grids and clouds, such as computing as a utility. When an open source leading the IT industry, why our webinar is not when? I'm sorry, that's not a question I can answer. How can we deploy our own application, Windows, Azure, anywhere? I'm sure there are enough tutorials on the Azure website. I would start there. I know they have a lot of tutorials on how to, so that might be a good place to start. I guess that's it. Thank you for your attention, and I hope this was helpful.
Thank you.
All right. I'm signing off now. Thank you. Bye. Good night.